Let's take a look at number 21. 21 says the length of AD in the figure shown above is. Then we have these segments. Let's take a look at our line segments. We have AC, BC, and BD. Now let's use that information to solve this problem. For example, the distances for line segments AC and BC are given. Let's take note that the difference of those line segments will be the distance for AB. AC is 24. Now let's take a look at BC. BC is 14. Now let's subtract. 24 minus 14 is 10. Now the distance for BD is also given. So the difference of that and BC will be the distance of CD. Let's highlight. BD is 22. BC is 14. Let's subtract 14 from 22. 22 minus 14 is 8. Now we can add up line segments AB, BC, and CD. 10 plus 14 plus 8. Let's add these together to get a total of 32. B, 32 is our answer. Now let's take a look at number 24. Which is the largest fraction? Now there are several ways to solve this problem. For example, we could use the bow tie method, or we could find a common denominator for the fractions. Now another option would be to convert the fractions to decimals. This will be a great opportunity to try that. So let's begin with A. Well, remember that the division sign means to divide by. So A is 3 divided by 5. Let's divide out 3 by 5. We can use long division. Three divided by 5. 5 does not go into 3. So let's add a decimal point and 0 to bring up that decimal point. 5 will go into 36 times with 0 remainder. 3/5 is equal to 0.6. Now let's convert 2/3. 2 divided by 3. We'll use long division again. 3 will not go into 2. Let's bring up our decimal point. 3 will go into 26 times. With 2 as a remainder, bring down the 0, we have a repeating decimal. We'll put that repeating decimal bar just above the 6. 0.66 on and on forever. Now let's convert C, 1/6. We'll divide 1 by 6. Six will not go into 1, so let's add our decimal place. 6 will go into 10 once, with 4 left over. Bring down our 0. 6 will go into 46 times, with 40 left over. We have another repeating decimal. And now 1/2. One divided by 2. 2 will go into 10 5 times. 0.5. Now we can compare and see which is the largest. The largest number here will be B. 0.67 is what that would round up to. B is our answer. Now let's take a look at number 25. Which lunch menu can be found in the shaded part of the figure above? This is like a Venn diagram where we have the similarities in the middle and the outliers are the differences. A compare and contrast type of thing. This is conceptualization. Using the figure here, let's bring these ideas into some context. So we have the shaded region will include lunches that include juice and a sandwich. We need to find the menu that includes both a sandwich and a juice. Only answer choice B provides us a menu that includes both a sandwich and juice. B is the correct answer. Now let's take a look at number 26. Which of the following shows a reflection? Now, an image that has been reflected has been flipped over a line. This will result in a mirror image of the original. We can imagine that if a fold could be made where each line is, then the two images would then fold together and appear as one image. Let's write this into our notes. An image that has been reflected has been flipped over a line, resulting in a mirror image of the original. We can imagine if a fold could be made where each line is, then the two images would then fold together and appear as one image. Now we only have one answer choice that matches this description. And that will be answer choice D. D is the correct answer. This is a reflection. Now let's take a look at 27. Which of the following produces a remainder of 3? Here we can use long division again to check each answer. Let's begin with A, 72 divided by 9. 72 is divisible by 9. Nine times 8 is 72. This will have a remainder of 0. Let's try 57 divided by 6. 9 times 6 is 54. This will give us a remainder of 3. This checks, good. Let's put a dot by B. What about 49 divided by 9? Nine times 5 is 45. With 4 left over, we have a remainder of 4 for C. And what about D? 39 divided by 7. Seven times 5 again will go into 39 with 4 remainder. We have a remainder of 0, a remainder of 4, and a remainder of 4. Our only remainder of 5 is 57 divided by 6, or answer choice B. B is our correct answer. Now let's take a look at number 28. Sam's Pizza uses 24 slices of pepperoni on 8 pieces of pizza. How many slices of pepperoni would be used on 6 pieces of pizza? If Sam is dividing 24 slices of pepperoni among the 8 pieces of pizza, each pizza will have, let's divide 24 divided by 8. Twenty-four divided by 8 is 3. Each piece of pizza will have 3 slices of pepperoni. Now, if one piece has 3 slices of pepperoni, then 6 pieces of pizza will have, let's multiply 6 times 3. 6 times 3 is 18. 18 slices of pepperoni in total. The correct answer is C, 18. Great, let's take a look at number 29. Evan is making a quilt out of 6-inch squares of material. How many squares will he need to make a quilt that is 6 feet long and 5 feet wide? Now first, let's convert the dimensions of the quilt from feet to inches. If the quilt is 6 feet long, and 5 feet wide, Then the quilt is, let's convert. 1 foot equals 6 inches. First we'll multiply 6 times 12. 6 times 12. Six times 12 is 72. Now let's multiply 5 times 12. 5 times 12 is 60. 72 inches long and 60 inches wide. Now let's find the area of the quilt and the area of each square. We can multiply 72 times 60. Here we can bring that 0 outside and just multiply our 6 times 2 is 12. 7 times 6 is 42 plus 1 will give us 43. 4,320. And 6 times 6. Six times 6 is 36. Now to see how many squares will be needed for the quilt, let's divide 36 into 4,320. Thirty-six will go into 43 one time. With 7 left over. 36 will go into 72 twice. With no remainder. Our result is 120. So 120 squares will be needed. Answer choice D is the correct answer. 120.